हेलो अस्सलाम वालेकुम, क्या हाल है आप लोगों के? हाउ आर यू? वी आर गोइंग टू डू थ्योरम नंबर 1, chapter 9, class 10. This is for English medium students. I've seen that if it is all in English, it will be good and easy for those uh, who are in English medium schools. So that's why I have decided to do Urdu separately and English separately. So if you look at this, look at the statement. It is written, one and only one circle can pass through three non-collinear points. What is the statement? One and only one circle can pass through three non-collinear points. Statement, and I have used another word for the statement also, that is enunciation. You can use your dictionary and find out its meanings also. I have explained in the previous video also while I was explaining theorem number 3 of this. Okay, so this is a statement. Now it is written, one and only one circle can pass through three non-collinear points. So what we have non-collinear points? If you look at these 3 points, A, B and C. So we have these A, B and C non-collinear points. Collinear means lying on the same line. Non-collinear means not lying on the same line. So if you look at points A and B, they are lying on the same line. But when we look at the C along with AB, then A, B, C becomes, they all become what? Non-collinear. Similarly, B and C are on the same line, and when we join with A also, then it becomes A, B and C, these three different non-collinear points. So given, look at this, A, B and C are three non-collinear points in a plane. What is a plane? This board, you can consider this board as a plane. Wherever you are sitting definitely in some room. So in that room there are 6 planes. One is the floor, one is the ceiling, okay, right and left walls, back and front wall also. Okay, so you can say they are all planes. Okay, so we have drawn this figure. We have three non-collinear points and we want to prove that only one circle can pass through this. Okay, so to prove one and only one circle can pass through these three non-collinear points A, B and C. So construction, what we have done construction, we have joined A with B and B with C. Then we have drawn DF perpendicular bisector of AB and HK perpendicular bisector of BC. Okay. Now look at the figure. What we have done? We have three non-collinear points. The first step is join A with B. Look at this construction. Join A with B, B with C. Then draw DF perpendicular bisector of AB. Now what is perpendicular bisector? It is that line which divides the line segment into two equal parts. It means AD will be equals to DB, also makes an angle of 90 degrees. Okay, what is the difference between perpendicular and perpendicular bisector? Perpendicular can be drawn here also, perpendicular can be drawn here also, but that is not going to bisect it. It means AB will not be divided into two equal parts. That is why when it is the word used right bisector or perpendicular bisector, okay, not only perpendicular, then it becomes, it should be dividing the line segment into two equal parts. It means AD will be equal to DB. At the same time, this angle will be of 90 degrees. Okay, understood? So we have drawn DF perpendicular bisector of AB. Similarly, we have drawn HK perpendicular bisector of BC. Any questions? Any difficulty? No? Easy? Okay. If you look at these two perpendiculars DF and HK, are they parallel? Like railway lines, they go together. Like bank of the river, they go along with each other, go parallel to each other, they never intersect. Similarly, if you look at these two, DF and HK, they are not going parallel to each other. So if they are not going to parallel to each other, they are going to definitely meet at some point. That is point of intersection. So that point is known as, we have named it O. What we have named with O. So okay. Now next. So read this construction again. Join A with B. We have done. Okay, and B with C. I've already explained. Draw DF perpendicular bisector of AB and HK perpendicular bisector of BC. I've already told. So DF and HK are not parallel to each other and they intersect each other at O. Sorry, I have already explained this. Any questions? No. Now we are going to go to proof. Very important part, proof. It has statement and reasons. Look at this. Every point on DF, what was DF? Perpendicular bisector of AB. Every point on DF is equidistant from the end points of the line segment AB between A and B. In particular, OA will be equals to OB. Similarly, when we draw, we take any point on the perpendicular bisector of this BC, okay, HK is the name, then OB will be equals to OC. I'm going to explain it on the figure, okay, then it will be very easy. So we have drawn perpendicular bisector DF of AB and we have taken any point. We can take here, we can take here, but if we take here and there, what is the reason? I'm going to explain it in the next step, okay, in the following steps, that if you take here and there, what will happen? Why are you taking only O? Okay, now we have taken point O, which is on the right bisector of DF. And in class 9th theorem, you have already done that any point taken on right bisector of a line segment AB, it is equidistant from endpoints A and B. So it means O is equidistant from A and B. If OA is 5 centimeter, OB will also be 5 centimeter. Similarly, we take here, then this point suppose MA will be equals to MB. Here if we take suppose S, then SA will be equals to SB. But we are interested only in which point? O, because that is the point of intersection of these two right bisectors. Reason I will tell you in the following steps. Okay, now next. Next is similarly, so OA has become equals to OB here. Look, done. Okay, now I will make OB equals to OC. Look at OB. Okay, this is point O. This is on the right bisector of BC. HK is the right bisector of BC. So O will be equidistant from B and O will be equidistant from C. So if OB equals to 5, OC will also be equals to 5. Or if OB equals to 3, OC will also be equals to 3. Okay, got it or not? Okay, uh, now we have proved OA equals to OC. How? Look at this again. OA equals to what? OB. OB equals to what? OC. So what is connection between OA and OC? See, OB is equal to OA, OB is equal to OC. So OA and OC will also become equal to each other. This line is not written in the book. I have written it so that it can make well easy fluent connection with the previous lines and the upcoming lines, so that you can make it very easy to learn it. Okay, now OA equals to what? OC. Why? Because OE is also equals to AB and OC is also equal to OB. Okay, OA equals to what? OB and OC equals to what? OB. So each equals to OB, so they will also be equal to each other. Like suppose if O equals to 5, OB will also be equals to 5, because here we have written. Okay, similarly, if OB 5, then OC will also be 5, because here we have written, look here. Okay, so similarly, you can say in this way, now all these three are 5 centimeters. OA will be equals to OB equals to OC. This line is written below this line. Here I have written up, so that it can go with sequence. Now, if you look at this now, OA, OB and OC all are equal. Then what was O? O was the point on the bisector of AB, that is DF, and O was also the point on the bisector of BC, that is HK. Got it? So that is why I have written, therefore O is the point only, O is the only common point. O is the only common point between DF and HK. Only common point between DF and HK, which is equidistant from points A, B and C. Here we have proved. Got it or not? Okay, we have already proved that O is equidistant from A 5 centimeter, B 5 centimeter, C 5 centimeter. So therefore, that what is written? Therefore, O is the only common point between DF and HK. What was DF and HK? Perpendicular bisector. Okay, so that is why we can say. Now I'm going to explain you. If we don't take O and take any other point, suppose we take here M. Okay, in the beginning I talked about it. So suppose if we take here M instead of O, we take M. This is right bisector. So point is taken on right bisector. So it will be equidistant from A, suppose 3 centimeter, equidistant from B, suppose 3 centimeter. So it means from A and B, this M point, supposed M point will be equal. Got it? But that M point will not be equal to MC. Got it or not? Because this line is longer than MB and MA. So that is why if we take any other point other than O, here or above, that will not be equidistant from all three points. Similarly, we take any point here, suppose, okay, we can take P. Okay, this P point will be equal to PB and PC, but not will be equal to PA. That is why there is only one possibility, and that is O. If we take point O, which is point of intersection of these two, what? Right bisectors, then only O will be equal to, then O's distance will be equal to OB's distance or OC's distance. Got it or not? That is why I have written, therefore O is the only common point between DF and HK, DF and HK, not any other point we can take. Okay, and between this which is equidistant from point A, B and C. Hence points A, B and C are lying on the circle. What is the reason? Now you know circle definition. The definition of the circle is, if you take distance from the center to any point on the circumference, suppose this is the circumference, okay, and you take distance from the fixed point O. So we have taken distance of this sort of circumference of point A, B and C, that is equal. Okay, if that distance is equal, it means definitely A, B, C will be lying on what? On the circle. Okay, on the circumference of the circle, because according to the property of the circle, any point taken on the circumference, okay, will be called radius from the center. And suppose OB will also be radius, OA will also be radius, OC will also be radius. So any point taken on the circumference and joined with the center, it becomes radius. So because OA becomes radius, OB also becomes radius, OC becomes radius, and these all radii are equal. So that is why we can say that now this all OA, OB and OC are the radii of the same circle. So this is only one circle possible, not any other. So that is why I have written, hence points A, B and C are lying on the circle with center O only. Hence proved that one and only one circle can pass through this. Got it? Any questions? Now I'm going to get a side. You can take it screenshot so that you can use it afterwards. Thank you so much. If you have any difficulty, you want to any suggestion want to give, okay, you can write down in the comments. Thank you so much. God bless you.